Hello my friend. Welcome back to You Can Do TV channel. The STIHL 075 is a heavy-duty chainsaw designed for large-scale forestry work. It operates with a 111cc two-stroke engine, providing ample power to handle tough tasks like cutting large cedar stumps. The engine uses a mix of fuel and oil to power the saw efficiently, and it is equipped with an electronic ignition system for reliable starting and optimal performance. The automatic oil lubrication system ensures the chain and bar are adequately lubricated, reducing friction during operation. Starting the chainsaw requires pulling the recoil starter, which can be challenging due to the engine's size. The STIHL 075 also features a chain brake for safety, preventing injury in case of kickback. The STIHL 090 is a powerful chainsaw designed for heavy-duty cutting tasks, particularly in forestry and large-scale wood processing operations. It is a part of STIHL's lineup of professional-grade equipment, known for its durability and high performance. The chainsaw is equipped with a V8 engine that provides substantial cutting power, making it suitable for felling large trees, cutting thick logs, and other demanding applications. Manufacturing of the STIHL 090 starts with the engine assembly, where the V8 engine is precisely constructed for maximum output and fuel efficiency. The carburetor, ignition system, and cooling system are installed to ensure smooth operation. The assembly line proceeds with the integration of the power head, bar, and chain, with each part manually and meticulously placed. Key safety features, including the chain brake and anti-vibration system, are carefully incorporated to ensure user protection during use. Once fully assembled, the chainsaw undergoes a series of rigorous tests to confirm engine performance, durability, and safety. Technicians assess its cutting ability, check for proper fuel efficiency, and test safety mechanisms. After passing all quality checks, the chainsaw undergoes a final inspection to ensure that all parts are correctly installed. It is then packaged and prepared for shipping to customers or distributors. The Big STIHL chainsaw is a powerful chainsaw designed for heavy-duty forestry work. The process of how it works starts with its high-performance 122cc engine. Which delivers 8.7 horsepower, enabling it to handle large cutting tasks with ease. This engine is engineered for fuel efficiency, providing greater performance while reducing exhaust emissions. The chainsaw utilizes the automatic lubrication system, which precisely lubricates the bar and chain, reducing oil consumption by up to 50% and enhancing operational efficiency. In addition, the Big STIHL chainsaw system makes starting the saw easier by minimizing recoil forces on the user. The chainsaw also features a durable HD2 air filter, ensuring clean air enters the engine, thus extending the life of the machine. To ensure user safety, the Mississippi 881 includes features like a chain brake and low kickback chains, critical for preventing accidents. This saw is intended for professional use and requires proper training to handle its power safely and efficiently. The Mississippi 881 is engineered for top performance, durability, and precision in forestry operations. The Pizzolatto TM1200 plus TB900 is a highly efficient firewood production system designed for processing large-diameter logs. This integrated system combines the TM1200 cutting group with the TB900 splitting station to provide a seamless and automated process for producing firewood. The TM1200 is equipped with a robust log handling system that can process logs up to 1,200 millimeters in diameter. Once the logs are cut, they are directed to the TB900 splitting station, which has the capacity to handle logs with diameters between 300 millimeters and 900 millimeters. The splitting station is powered by a 22 kilowatts motor, providing a splitting force of 40 tons, which ensures that even large logs are efficiently divided into smaller firewood pieces. The system's automatic feeding control adjusts according to the log dimensions, optimizing the splitting process. Logs are fed into the system via a 30 millimeters thick feeding tube, capable of handling logs up to 6 meters long. The cutting mechanism includes a horizontally sliding chain with vertical movement, ensuring precise and efficient cutting. This cutting group is fully automated, featuring a control panel platform with photocells to measure the log lengths and automatically make the necessary cuts. This automated system reduces manual labor, increases productivity, and provides a reliable solution for producing high-quality firewood in large quantities. Together, the TM1200 and TB900 create a highly efficient firewood production line, streamlining the process from cutting to splitting. Wood selection. The process begins with selecting the right type of wood, typically ash, birch, or pine. The wood must have a uniform grain to ensure a smooth, durable final product. Once chosen, the wood is cut into a cylindrical shape, forming a blank that serves as the base for turning. Bowl turning without electricity, demonstrated by Giraud and Pierman-Lair, is a time-honored method of creating wooden bowls using a foot-powered pole lathe. This technique eliminates the need for electricity and relies purely on human power, highlighting sustainability and traditional craftsmanship. Setting up the pole lathe. The pole lathe used in this process is a simple yet effective tool powered by the operator's foot. The lathe consists of a long wooden pole, a rotating spindle, and a foot pedal connected to a rope. As the artisan pushes the pedal, the rope moves, turning the spindle, which rotates the wooden blank. The beauty of the pole lathe is its mechanical simplicity, using only foot power and minimal moving parts. Securing the wood blank with the lathe in place, the wood blank is mounted. One end is fixed securely, while the other end is placed on the rotating spindle. This ensures the wood spins evenly, essential for producing a smooth, uniform bowl. The setup allows for precise control over the shaping process, enabling the artisan to carve the wood efficiently. Turning the bowl. The turning process begins with the artisan working the foot pedal to rotate the blank. Using a variety of tools, including chisels, gouges, and knives, the artisan removes excess wood and begins to shape the exterior of the bowl. The speed of the lathe is regulated by the force applied to the foot pedal, light pressure for slow, controlled cuts, and heavier pressure for quicker, rougher shaping. Shaping the bowl. After the exterior is shaped, the artisan then focuses on hollowing out the inside of the bowl. This step requires careful attention to ensure an even thickness and smooth, symmetrical curves. Specialized tools are used to remove material efficiently and avoid imperfections. As the interior takes shape, the artisan ensures that both the interior and exterior match in design and quality. Finishing the bowl. Once the shaping is complete, the next step is sanding. Sanding is crucial to smooth out any rough edges or tool marks left during the turning process. The artisan typically uses a progression of finer sandpapers to achieve a smooth and refined surface. This process brings out the wood's natural beauty, highlighting its grain and adding a polished touch to the finished piece. Applying a finish to protect the wood and enhance its appearance, a finishing product is applied. Natural oils or waxes are often used to seal the wood, giving it a glossy finish and protecting it from moisture and wear. This step not only protects the wood, but also deepens its color and highlights the grain pattern, giving each bowl its unique character. Conclusion. Bowl turning without electricity is a meticulous and skillful process that requires patience and expertise. Using a pole lathe, artisans can create beautiful, functional bowls without the need for electric tools, relying on manual power and traditional methods. From wood selection to the final finish, every step in the process is performed with care and precision, ensuring high-quality results. This technique not only preserves an ancient craft, but also serves as a testament to sustainable and low-tech methods in modern-day production. The first step involves carefully selecting high-quality oak, typically French oak, known for its strength and ability to enhance the flavor of wine. After the oak logs are harvested, they are split into staves or duels, which are the individual wood pieces that will form the barrel's sides. These staves are then seasoned, either by air drying for up to 3 years or kiln drying to ensure the right moisture content for shaping. The next phase involves shaping the staves. They are cut to precise dimensions, then steamed and heated to make them flexible enough to be bent into the curved shape required for the barrel. This bending is achieved either manually or using specialized machines, allowing for accurate shaping. Each stave is measured and adjusted to ensure a perfect fit, and the staves are gradually assembled into the barrel's desired shape. Once the staves are prepared, the barrel assembly process begins. The cooper, or barrel maker, arranges the staves in a circular formation and secures them with metal hoops. These hoops are carefully adjusted to ensure the staves are tightly secured and the barrel is watertight. The bottom and top of the barrel are meticulously crafted and inserted to complete the structure, and final adjustments are made to ensure the barrel is perfectly aligned. After assembly, the barrel is toasted, a crucial step in the process, particularly for winemaking. The toasting process, carried out by heating the inside of the barrel with controlled flames, caramelizes the natural sugars in the wood, influencing the flavor profile of the wine that will be stored in the barrel. The level of toasting varies based on the wine's requirements, impacting its flavor and color. Once the toasting is complete, the barrel is given its finishing touches. The exterior is sanded to remove rough edges, and a protective treatment is applied to prolong the barrel's life. The barrel is then filled with water to check for leaks, and any necessary adjustments are made. Finally, before being sent out for use, the barrel undergoes thorough quality control. This includes checking its structure, toasting consistency, and leak-proofing. The production of premium barrels at Art du Tonneau, under the direction of Frédéric Gillet, combines traditional craftsmanship with modern technology in a detailed, step-by-step process that begins with selecting the finest raw materials and progresses through a blend of manual skills and machine assistance to create a barrel suitable for winemaking. Only barrels that pass these rigorous tests are considered ready for high-end winemaking. Through this detailed process, Art du Tonneau ensures that each barrel not only serves its functional purpose, but also enhances the aging and flavor of wine, blending traditional techniques with modern precision. It starts with the selection of the finest oak wood, typically French oak, which is renowned for its durability and flavor-enhancing qualities. These staves undergo a seasoning process, either by air drying for several years or by kiln drying, to ensure the optimal moisture content before further processing. Once prepared, the staves are heated and steamed to make them flexible. This allows them to be bent into the curved shape required for the barrel. This step can be done manually or with the aid of specialized machines, depending on the precision and scale needed. Next, the staves are assembled into a cylindrical shape, and metal hoops are used to hold them in place. The bottom and top of the barrel are carefully crafted and inserted. The structure is then adjusted to ensure a perfect fit, ensuring that the barrel is watertight. After the basic assembly is completed, the barrel undergoes a toasting process. The inside of the barrel is heated with controlled flames, which caramelize the natural sugars in the oak and contribute specific flavors to the wine. The oak logs are carefully chosen and cut into staves, known as duels, which are the individual pieces that form the body of the barrel. To produce high-quality oak barrels and casks, the process integrates both traditional craftsmanship and modern technology. The final stages involve finishing touches, such as sanding the exterior to smooth out rough edges, and applying a protective treatment to extend the barrel's longevity. A water test ensures there are no leaks before the barrel is ready for use. Through this meticulous process, oak barrels are created to enhance the aging of wine, combining time-honored techniques with precise modern craftsmanship. The production process in the timber processing industry is highly detailed, with various steps ensuring the efficient production of timber products like planks, beams, and wood chips. The band sawmill, canter slabber, and digital carriage are essential components in this process, each playing a vital role. Band sawmill operation. The process begins with the band sawmill, where raw logs are fed into the machine for cutting. This sawmill utilizes a bandsaw, which is a long, continuous strip of metal, with teeth that can slice through logs with precision. The logs are positioned and clamped into place by automated systems to ensure accurate cuts. The band sawmill is designed to produce smooth, high-quality planks or timber pieces, minimizing waste and maximizing the yield from each log. The system operates through advanced hydraulic and mechanical systems that ensure smooth operation, adjusting automatically based on the size and type of the log. Canter slabber. After the band sawmill, some logs may require additional processing. The canter slabber is used to remove the outer layers of wood from the logs, ensuring that only the usable part is retained. This machine cuts the log into slabs, which are further processed to create wood boards or other products. The canter slabber is equipped with a powerful motor and precise cutting tools to handle large and thick logs, preparing them for the next phase of production. Digital carriage system. The digital carriage system is an automated system that transports the processed wood from one machine to another. Using advanced sensors and digital technology, it ensures that the timber is moved precisely to the right location within the facility. The system can operate seamlessly, reducing human error and enhancing efficiency by automating the movement of timber through the factory. This entire process allows for the efficient transformation of raw logs into finished timber products with minimal waste and maximum speed. It requires skilled operators, advanced machinery, and an integrated system to achieve the high level of precision and quality expected in the industry. The process begins with the precise selection of raw materials, primarily high-quality wood such as pine or oak, chosen for their strength and durability. The wood is then cut into appropriate lengths and prepared by drying to reduce moisture content, ensuring the drums are lightweight yet strong. The production process of wooden cable drums involves a series of carefully orchestrated steps combining manual labor and advanced machinery to create durable and high-quality drums used for cable storage and transport. This process, which combines traditional craftsmanship with modern manufacturing technologies, ensures that each wooden cable drum is capable of handling the heavy demands placed on it during its use. The machines involved in the production process are carefully calibrated to ensure consistency, speed, and quality throughout the entire operation. Human operators oversee the machinery, ensuring that each drum meets the precise specifications needed for various applications. Quality control procedures are integral, ensuring that every drum is tested for strength, durability, and proper functionality. With the integration of modern technologies and skilled craftsmanship, the wooden cable drums are produced with consistency and reliability, meeting the high demands of industries worldwide. Next, the prepared wood is fed into specialized machines for shaping and cutting. This includes the use of circular saws and planers to ensure that the pieces are uniform in size and shape. The key components of the drum, such as the barrel, flanges, and center hubs, are then assembled using precise measurements. These components are either joined using screws, nails, or other fasteners, and in some cases, glue is applied to enhance strength. Automated machines are used to ensure accurate alignment and fitting, enhancing the overall durability of the drum. Once the primary structure is assembled, the wooden drum undergoes sanding to smooth out rough edges and ensure the surfaces are free of imperfections. This step is crucial to prevent any damage to the cables when they are wound onto the drum. The use of automated machinery for cutting, sanding, coating, and assembly ensures that the production line runs smoothly and efficiently, allowing for large-scale production without compromising on quality. Once completed, the wooden drums are ready for use in a wide range of applications, including the storage and transport of electrical cables, telecommunications wires, and other industrial materials, ensuring that the drums are strong enough to support heavy loads while maintaining their structural integrity throughout their use. After sanding, the drums are coated with a protective layer, such as varnish or paint, to provide additional resistance against moisture and environmental elements. This coating is applied using automated spraying systems, ensuring an even layer that provides long-term protection. The final product, whether it's a small or large cable drum, is designed to meet the rigorous requirements of industries such as telecommunications, energy, and construction. The automated production line allows for fast, efficient production while maintaining the high standards required for cable drum quality. From raw wood selection to the final inspection and shipment, the entire process is designed to optimize efficiency and minimize errors. The final stage involves quality control checks, where each drum is inspected for structural integrity, size accuracy, and surface finish. Any drum that fails to meet the required standards is either repaired or discarded. Once approved, the drums are packaged and prepared for shipment. They are often wrapped in protective materials to prevent damage during transport. The entire production line is highly automated, but manual supervision is required at various stages to ensure that everything is running smoothly. To produce a high-quality rowing boat, Hackler Boot Bow follows a meticulous production process that combines advanced technology with traditional craftsmanship. Each step is carefully executed to ensure the boats meet the highest standards of durability, performance, and aesthetics. The process begins with understanding the customer's needs. The Hackler Boot Bow team collaborates with the client to gather detailed specifications, including desired dimensions, type of wood, and aesthetic preferences. After gathering all relevant information, the design is finalized using computer-aided design (CAD) software. This allows for precise measurements and ensures the boat's structure will meet performance standards. Hackler Boot Bow places great emphasis on selecting the best materials to ensure longevity and performance. High-quality woods such as teak, pine, and oak are chosen for their strength, buoyancy, and resistance to weather conditions. The choice of material directly impacts the boat's performance on water, as well as its overall durability. Once the materials are selected, the next step involves processing the wood into specific shapes and sizes. The team cuts and mills the wood according to the design specifications. Specialized machinery is used to cut the wood precisely, ensuring every part fits perfectly. The precision cutting is essential to maintain the integrity of the boat structure and ensure that the components align correctly during assembly. A protective layer is then applied, often in the form of varnish or paint, to provide both aesthetic appeal and added protection against the elements. Before being handed over to the customer, each boat undergoes rigorous quality checks. The boat is tested for buoyancy, structural integrity, and overall craftsmanship. Only boats that pass these tests are approved for delivery. Hackler Boot Bow ensures that every boat meets their strict standards for safety and performance. Skilled craftsmen carefully assemble the boat's frame, starting with the hull, followed by the deck and other structural components. The boat is constructed in stages, with each component being carefully fitted to ensure the final product is both robust and stable. Once the assembly is complete, the boat undergoes a thorough surface treatment process. The surface is sanded to a smooth finish, removing any imperfections and preparing it for coating. After passing quality control, the boat is delivered to the customer. Along with the boat, customers receive detailed instructions on maintenance and care to ensure the longevity of the boat. The Hackler Boot Bow team provides full support to help customers learn how to properly handle and maintain their new boat. This process blends state-of-the-art machinery with expert craftsmanship, ensuring that each boat produced is a masterpiece, ready for the water and designed to last for many years. The production of cable rolls from plywood, triplek, involves a detailed process, blending manual craftsmanship and mechanical tools. First, high-quality plywood is selected based on its thickness and size, ensuring it can withstand the weight and stress of the cable roll. The plywood sheets are carefully cut into precise dimensions according to the desired roll size. The next step is preparing the core for the roll, which is typically made from bamboo or PVC pipes. These materials are cut to the required length, as they will serve as the central axis for the roll of cable. Once the plywood is prepared, holes are drilled at the center of each sheet to fit the core material securely. Afterward, the bamboo or PVC core is inserted into the plywood sheets, ensuring that the core is centered and stable. This is crucial for ensuring smooth and even rotation when the cable is wound onto the roll. The core and plywood are then assembled, and the structure is tested for stability and balance. The entire production line works together, from the initial selection of materials to the final product inspection, ensuring that each cable roll is both functional and reliable. In some cases, custom specifications may be requested by clients. Requiring adjustments to the standard process. The production of these cable rolls is vital for industries requiring organized and accessible cable storage, such as construction, electrical work, and telecommunications, where the ability to quickly access and deploy cables is crucial. In a larger-scale production, automation and specialized machines may be used to streamline the cutting, assembly, and winding process, allowing for greater efficiency and consistency. These machines typically handle the cutting of plywood, the creation of the core, and the winding of cable, all while maintaining high standards of precision and quality control. The cable is carefully wound around the core, with the plywood sheets forming a sturdy frame that keeps the cable in place and prevents tangling. This step can either be done manually or with the aid of machinery, depending on the production scale. The assembly is monitored to ensure that the cable is wound evenly and tightly, preventing any kinks or damage to the wire. The final product is a durable cable roll, which is inspected for quality, ensuring that the core is stable and that the plywood sheets are securely attached. Once the rolls are completed, they are ready for shipping or further processing. The manufacturing process begins with the careful selection of high-quality materials for each component. The aluminum body is precisely machined, ensuring a perfect fit for all parts. Key components such as the brushless motor and lithium-ion battery are also produced to exact specifications to ensure seamless integration. Skilled technicians then assemble the pruning shears, integrating the motor, battery, and electronic systems into the aluminum housing. The tool features interchangeable cutting heads, available in standard, medium, and maxi options, to allow for versatility and precision in different pruning tasks. The INFACOEL ECTROCOUPF 3015 is an advanced electric pruning shear tailored for professional use in viticulture, orchards, and horticulture. Developed with meticulous precision, the F3015 ensures high performance and reliability in demanding environments. Its compact and ergonomic design features a body made from a special aluminum alloy used in aeronautics, providing an optimal balance between durability and lightweight construction. The aluminum housing comes with a lifetime warranty, reflecting the product's robust design and long-term reliability. To ensure each unit meets the highest standards, the F3015 undergoes rigorous quality control testing. Each shear is carefully inspected to verify the functionality of the cutting mechanism, the efficiency of the battery, and the overall ergonomic design. Once passed, the tool is ready for professional use. Powered by a brushless motor and lithium-ion battery, the F3015 delivers consistent cutting power for efficient pruning. Users can select the most suitable cutting head and adjust the half-opening modes for better precision, depending on the task. Safety is a priority in the design of the F3015, which includes a patented conductive trigger system that connects the user's body to the shear's electronics, reducing the risk of injury. Additionally, the tool automatically enters standby mode after periods of inactivity to conserve battery life. Regular maintenance is essential for ensuring optimal performance, including blade sharpening, lubrication, and daily inspection. The INF ACOELECTROCOUPF 3015 is a top-tier reliable tool for professionals who require precision and durability in their pruning tasks. The process starts when branches or logs are fed into the machine's input chute. The motor then drives the blades of the chipping mechanism, which rotate at high speed to shred the material into smaller pieces. The chips are collected in a designated container or bin for easy disposal or further use as mulch, compost, or fuel. The robust motor ensures continuous operation, even when processing dense or tough materials, making the Urban EM110 highly reliable in demanding conditions. The Urban EM110 is a powerful electric wood chipper designed for efficient processing of wood waste, such as branches and logs, with a maximum diameter of 12 centimeters. It is equipped with a robust Siemens 3-phase electric motor rated at 18.5 kilowatts, which ensures high-performance processing of various materials, including waste materials like boards and battens. The motor's power is transferred to the chipping mechanism through V-belts, driving an oil-filled gearbox that enhances the machine's operational efficiency. This wood chipper is specifically designed to handle materials up to 12 centimeters in diameter, allowing for the easy and fast reduction of wood waste into smaller chips. The resulting wood chips have a length ranging from 7 to 22 centimeters, depending on the material and machine settings. The Urban EM110 is ideal for use in various environments, including gardens, forestry operations, and industrial settings, where large amounts of wood waste need to be processed. One of the key features of the Urban EM110 is its oil-filled gearbox, which provides better lubrication and extends the lifespan of the machine, ensuring smooth operation for long periods. Additionally, the machine is designed for easy maintenance, with simple access to critical components for servicing and cleaning. The machine's compact size and efficient design make it a versatile choice for both professional and home use, particularly for those who require a high-performing yet environmentally friendly solution for wood waste management. For industrial or large-scale operations, the Urban EM110 can be integrated into a larger waste processing system, working alongside other equipment for efficient material handling. It can process a wide range of materials, from smaller branches to large logs, making it a valuable tool in reducing wood waste and producing reusable chips. Whether used in landscaping, forestry, or recycling operations, the Urban EM110's combination of power, efficiency, and ease of use makes it an essential machine for managing wood waste effectively. Cutting down an oak tree requires a strategic approach, precision, and the right equipment. The process begins with assessing the tree's condition, size, and location to ensure safety. The ideal felling direction is determined based on the tree's lean and surrounding environment. Next, the area around the tree is cleared, creating a safe space for the tree to fall and a clear escape route for the operator. The cutting process starts with a notch cut, made on the side facing the desired direction of the fall. This notch helps control the tree's direction and ensures it falls safely. The notch is followed by a horizontal cut slightly above it. Then, on the opposite side of the tree, a horizontal felling cut is made just above the notch cut. This cut should be level with the notch and slightly to the side, ensuring the tree falls in the intended direction. Modern machinery such as chainsaws or specialized felling equipment is used to make the cuts. These tools must be well maintained for safety and efficiency. During the felling process, safety is paramount, and operators wear personal protective equipment, PPE, including helmets, gloves, and chainsaw chaps. Additionally, coordination with a team is essential for maintaining control of the operation. Once the oak tree is felled, the next step is usually logging, where the tree is sectioned into manageable pieces and the wood is prepared for its intended use. The STIHL 090 is a vintage yet powerful chainsaw, produced between 1968 and 1977, primarily designed for professional forestry and heavy timber cutting. Powered by a 137cc engine, producing approximately 8.5 horsepower, the 090 is capable of handling large and demanding cutting tasks, such as felling big trees and processing thick timber. The engine operates on a two-stroke cycle, mixing oil and fuel to produce the necessary power for the chainsaw. This simple yet efficient design contributes to the saw's excellent power-to-weight ratio, making it suitable for tough forestry work. The electronic ignition system ensures reliable starting and smooth engine performance by providing an optimal spark, thus improving fuel efficiency and reducing emissions. The chainsaw uses a manual lubrication system where the operator pumps oil to lubricate the bar and chain, reducing friction and ensuring smooth cutting operation. To start the STIHL 090, the operator uses a recoil starter, which requires a firm pull due to the engine's size. It's recommended that two people work together when starting the chainsaw for better control and safety. Safety features like the chain brake, which halts the chain's movement during kickback, help protect the operator. However, given the age of the STIHL 090, operators should use it with caution, ensuring proper training and safety gear to avoid accidents. The STIHL Mississippi 881 is a high-performance chainsaw designed for professional forestry work. It features a robust 121.6cc engine delivering 8.7 horsepower, making it one of the most powerful chainsaws available. The saw operates with a 2MIX engine, which combines high power with reduced fuel consumption and lower emissions. It's equipped with an pneumatic lubrication system that optimizes the oiling of the chain and guide bar, reducing oil consumption by up to 50%. The Mississippi 881 also features a HD2 air filter, which captures fine dust particles and enhances the engine's longevity. The IntelliCarb carburetor automatically adjusts the air-fuel mixture when the air filter becomes clogged, ensuring consistent performance. The chainsaw's quick-stop brake system provides an added layer of safety by stopping the chain in the event of a kickback. The Mississippi 881 is designed with user comfort in mind, featuring an anti-vibration system and a master control lever for easy operation. This powerful and efficient chainsaw is perfect for heavy-duty tasks in demanding environments. The V8-powered hot saw combines a powerful V8 engine with a large saw blade, designed for cutting large logs quickly. The engine drives the blade via a gear or belt system, while a robust frame supports the entire mechanism. Safety features and cooling systems ensure smooth operation in challenging cutting tasks. The STIHL Mississippi 660 chainsaw is engineered for professional forestry work. It operates with a 91.6 cc engine, delivering 7.0 horsepower for efficient cutting through thick timber. The engine uses a two-stroke cycle, mixing fuel and oil for power, with an electronic ignition system for reliable starting and consistent performance. The saw utilizes a manual oil lubrication system to reduce friction and ensure smooth operation. The recoil starter requires a firm pull to engage the engine. Additionally, the Mississippi 660 includes safety features such as a chain brake to stop the chain in case of kickback, ensuring user protection during operation. The MB Track is a versatile tractor, widely used in forestry for skidding large logs, such as beech butts. In these operations, the MB Track is equipped with a dual winch system, often from Werner, to pull heavy timber from dense forests. The process begins with the tractor navigating through rough terrain to reach the logs. Once in position, the winch pulls the logs toward the tractor, where they are securely loaded and transported. The efficient system allows for the rapid extraction of large logs, minimizing the time spent in forest operations and increasing productivity. Proper maintenance and operator training ensure long-term effectiveness. Transporting logs from deep forests to lumber mills is a challenging task, especially when navigating dangerous, winding forest roads. The 1974 Kenworth truck, famously known as Big James, plays a crucial role in this process, hauling massive loads of timber from remote logging sites like the Red Barn logging job. The Kenworth Big James, with its robust engine and reinforced frame, is specially built to handle oversized loads, steep inclines, and tight corners that are common in forest roads. Equipped with positive differentials, the truck maintains traction even on slippery, muddy terrain, ensuring it can climb sharp grades and navigate uneven surfaces. Cut-off trucks follow behind, used to carry shorter or leftover log segments that Big James cannot haul in one trip. These support trucks help ensure that no usable wood is left behind, increasing efficiency and minimizing waste. Driving these narrow, twisting mountain roads requires extreme caution and experience. Operators must manage engine braking, avoid sharp rollovers, and navigate switchbacks with inches to spare. Weather adds another layer of difficulty. Rain turns paths into slick mud, while snow and ice demand precise control and constant adjustments. Despite the risks, this transportation chain is vital. Once out of the forest, the timber is delivered to sawmills, where it is processed into lumber for construction, furniture, and other industries. In the world of logging, trucks like Big James are more than machines. They are lifelines connecting remote forests to modern infrastructure, driven by operators who face danger daily to keep the wood supply moving. Driving a logging truck is one of the most dangerous jobs in the transportation industry. Each year, logging truck drivers face extreme hazards as they transport heavy timber loads from remote forests to processing mills. According to the U.S. Bureau of Labor Statistics, logging has consistently ranked among the top 5 deadliest occupations, with a fatal injury rate of over 70 deaths per 100,000 workers, far above the national average. The risks begin with the environment. Logging routes are often narrow, winding, and unpaved, cutting through dense forest and mountainous terrain. Drivers must maneuver 40 to 50-ton trucks on slippery mud, steep slopes, and tight curves, sometimes with only inches of clearance. A single miscalculation can cause a truck to tip, roll, or slide off a cliff. Mechanical failure is another serious risk. A broken brake, tire blowout, or malfunctioning differential can be catastrophic, especially when descending steep grades with a fully loaded trailer. Logging trucks also often operate in harsh weather. Rain, snow, and fog reduce visibility and traction, increasing the chance of accidents. Fatigue is a hidden but deadly factor. Long hours and irregular shifts mean drivers are often working under physical and mental stress. In 2022 alone, over 60 logging truck-related fatalities were reported in the United States, many due to loss of control or collisions. Despite modern safety systems, the nature of the job remains high risk. Logging truck drivers require skill, concentration, and physical endurance to survive daily tasks. Their role is critical in the timber supply chain, but it comes with a cost: constant exposure to life-threatening conditions. This trailer crane setup is designed to lift heavy logs with ease. Using a 1000 lb capacity crane mounted on the trailer, it can handle substantial hardwood, like a 12-foot oak log, without issue. The hoist is powered by a 6000 lb worn winch mounted to the back of my Jeep, providing plenty of pulling strength and control. Whether in the forest or at the woodlot, this compact yet powerful configuration allows safe and efficient loading of long, heavy logs, making it ideal for firewood processing or timber hauling tasks. Unloading logs from the trailer is made easy with a second winch setup. While the 6,000 pounds Warren winch on the back of my Jeep handles most lifting tasks, a super winch EP 12,500 pounds mounted on a second vehicle was used to unload from the trailer's rear tailgate. This setup provided more pulling power and better angle control. The logs were approximately 4 feet long and 20 inches in diameter, making them hefty but manageable. A log tong from Princess Auto securely gripped each log. For better lift leverage, the second winch's cable was connected to a large tree, using a tree saver strap placed about 7 feet high. This elevated anchor point assisted in the lift and reduced strain on the winch system. The dual winch, dual vehicle approach allowed for safe, controlled unloading, even in remote and uneven terrain. This firewood log trailer is built with both loading and unloading capabilities in mind, offering a self-sufficient solution for handling heavy timber in rugged or remote environments. The trailer features a mounted crane capable of lifting up to 1,000 pounds, operated via a 6,000 lb Warren winch mounted to the rear of my Jeep. This system makes it easy to lift and position long logs, such as a 12-foot oak, onto the trailer for transport. Unloading is handled through a second setup, a super winch EP 12,500 pounds mounted on another vehicle. For added leverage, the winch cable is anchored to a nearby tree, using a tree saver strap about 7 feet up the trunk. This elevated pull point assists in lifting and guiding logs off the trailer safely. Four-foot-long logs, 20 inches in diameter, are gripped using a sturdy log tong from Princess Auto. The trailer's design allows one person to efficiently load and unload firewood without additional equipment or manpower. Whether processing firewood for winter or transporting felled timber, this trailer system offers mobility, power, and convenience for serious wood handling needs. It's a practical solution for anyone cutting and hauling their own firewood.